Talking of the variation of g with depth, here one thing is most important, that is when we talked of the variation of g with the altitude, there the mass of the earth remained constant, but when we dig a hole into the earth, when we go deep down the earth, that means the mass beneath the depth decreases. That means if we are calculating the value of g dash here, that means we are down with the depth d, that means the mass of the earth is not m, the mass of the earth is m dash. So we have to keep in mind that the value of g is equal to gm divided by r square. Here not only the r changes but m also changes. At the surface of earth, we know that g is equal to gm divided by r square. When we talk of the acceleration due to gravity, here we have to take m dash and we have to take the distance or the radius equal to r minus d. Rest is calculation. So g dash is equal to gm dash divided by r minus d whole square. Now as we know that if we take the earth as a perfect sphere, the mass of the earth with radius r comes out to be density into volume, that is 4 by 3 pi r cube into rho, and the mass m dash at a point beneath this point equals to be 4 by 3 pi r minus d whole cube into rho. As the density is same but as the radius is less, so this mass should be less. Let this be equal to 1 and let this be equal to 2. Dividing second by first, we have g dash divided by g is equal to gm dash divided by r minus d whole square into r square divided by gm. Now substituting the values of m dash and m here, we have got m dash equal to 4 by 3 pi r minus d whole cube into rho divided by r minus d whole square into r square divided by 4 by 3 pi r cube into rho. Now this 4 by 3 pi goes this row and rho goes, r square and 3 goes, we are left with r, 3 and this goes, we are left with r minus d, so that is equal to r minus d divided by r. If we take r common in the numerator, we are left with r into 1 minus d by r divided by r. This r and r cancels out, so we have got g dash divided by g is equal to 1 minus d by r. That means g dash is equal to g into 1 minus d divided by r. So if d is equal to r, that means at the center of the earth, g dash is equal to g into 1 minus r divided by r, that is equal to 0. So at the center of earth, the value of acceleration due to gravity is 0. That is obvious because at the center of earth there should be no mass, so no gravity. So g dash is equal to g minus dg divided by r. So decrease in value of g is g minus g dash, that is equal to dg divided by r. This is decrease in value of g. If we are going to calculate a fractional decrease in value of g, that is g minus g dash divided by g, that is equal to d by r. If we are going to calculate the percentage decrease in g, that means percentage decrease in g, that is equal to g minus g dash divided by g into 100, that is equal to d by r into 100. This is percentage decrease in the value of g. So with height, the value of g decrease, and with the depth, the value of the g decrease. The value of the g is most at the surface of the earth or near the surface of the earth, when we can neglect the small heights, that is equal to 9.8 meters per second square. So the gravitational acceleration is not a constant. Thank you.